Hello students, today we are going to take up the topic Faraday's laws of electrolysis. It comes under chapter 3rd of electrochemistry, standard 12, ICSE, CBSE and state boards. Let us start. Thought for this session is person who never made a mistake, never tried anything new. So means to say that of course when you are trying new things, mistakes are possible, and what we have to do is we have to learn from that mistakes and move forward, because it's the way. Like for example, there are 99 way of solving the problems, or we are able to know that which is the best way to come out from that problem. So this is what the thought says, that we can make mistakes, but we should learn from the mistakes, and the mistake we should not repeat it again. That's the point. And there is no point of thinking that okay, I have done mistakes. Mistakes are there for our improvement. Next is learning outcomes. So you would be able to explain basics of electrolysis. Faraday's law of electrolysis, first law, second law, numericals on Faraday's laws, applications of electrolysis. Let us start. So basis of electrolysis, I will start from very basics. For electrolysis to take place, we need electrolytic vessel. So please, electrolytic vessel, I am not talking of electrochemical vessel. Electrochemical is producing the electricity. Here it is consumption of electricity takes place. Please make sure you are clearing this point. Electrodes, two electrodes are there as in the cell, cathode and anode, but the signs are opposite. Electrode, cathode is negative charge and anode is positive charge in electrolytic cell, but in electrochemical cell it is opposite. Positive ions, that is cations, gets discharged at cathode. It means positive charge are moving towards cathode and negative charge and ions are moving towards anode. Now the one more point we have to understand is, at anode oxidation takes place. And what is oxidation? Oxidation is loss of electrons. Next is the reduction. Reduction at cathode. Reduction takes place at cathode, and reduction is what? Gain of electrons. It means to say that positive ions are moving towards cathode, undergo reduction, which is gain of electron. Similarly, negative ions, that is anions move towards anode, which undergo oxidation and which is loss of electron. Electrolyte normally can be a metal salt solution, like copper sulfate we are doing. So copper sulfate solution, acidified, so to improve the ionization, so ion formation, aqueous or molten state, both can be possible. Next is we have to use DC supply, because otherwise the sign will be opposed after each cycle of electricity, and whatever is material is discharged, the reactions will go reverse. So that's why DC electricity is supplied to do electrolysis. And as I have told earlier, the electrolysis is energy consumption takes place, and electrical energy is converted to chemical energy, and moreover decomposition of an electrolyte takes place, which is not in case of the electrochemical cell. Next is example. Let us understand this basics with this one example. We are doing copper sulfate electrolysis in aqueous medium. Electrolytic cell we are taken. Electrolyte is aqueous copper sulfate with a dilute sulfuric acid to improve the ionization of copper sulfate, and water also ionized to give H plus and OH. Now here in this problem we are having two types of cations, like copper 2 plus and H plus, which will move towards cathode. That will be decided by the selective discharge. What is selective discharge? Selective discharge depends on number of factors like concentration and the position in the positive series and the inertness. But for the time being, you can understand that which is having the more tendency for reduction, or which is having the more value of E naught reduction value. E naught reduction value is more for copper 2 plus as compared to H plus. That's why copper 2 plus gets discharged at cathode, which undergo reduction. Reduction is gain of electron. Next is anode. Anode, there are two types of ions at anode, OH negative and sulfate. Now you know that both can go towards anode, but which is going OH negative? Why preferential? Preferential means this OH negative ion is having more tendency for oxidation, or we can say that is having more E naught oxidation value, or we can say that it is having less E naught reduction value. Okay, so reduction and oxidation are opposite to each other. So if you are not a little bit clear, I feel that you should just go back and read and revise the reduction potential and oxidation potential once more. Next is oxidation at anode, loss of electron, anion move towards anode, DC electricity supply is used, copper ions having preference over H+, that I have explained to you that how it is there. Okay, let us start with the basic laws of electrolysis now. Now, what is the practical application? What are the practical applications for electrolysis is to give a new look to article made up of metal. For example, I am having the pen made up of, let us say, silver cap is there, and I want to coat with the golden cap. So that we can do electrolysis. So fine. So second thing is to refine metal. Like I want to improve the percentage purity of copper from 65 to 99%. We have to use electrorefining. Similarly, if I want to prevent the corrosion, like see the bridges and the iron bridge structures, and this to prevent the corrosion, we are using the electrolysis technique or galvanization, or different techniques are there to prevent the corrosion. Next is GI wires also, galvanized iron. Normally we may not be knowing what is GI wire. GI is galvanized iron. Its pipes also and wire also is possible. Next is to get chemical substance such as sodium hydroxide. Like for example, +1 we have stated that we are getting sodium hydroxide through Castner-Kellner's process that undergoes the electrolysis. The same way, these are the practical applications of electrolysis. Now we will discuss about the Faraday's laws of electrolysis. Now we understood the basic points of electrolysis. Now we will take up Faraday's law of electrolysis. First law says that the mass of substance deposited or liberated. So deposited word is used for the solid and liberated word is used for the gas. The mass of substance deposited or liberated at any electrode means at a node or cathode, is directly proportional to the amount of charge passed. Charge means current. Current means I is equal to Q by T. So we are not talking about here I, we are talking of Q. Q means IT. So whenever students are saying that mass of substance deposited or liberated at an electrode is directly proportional to the current, they are not writing the definition in a proper way. We should write I into T, not I only. So that's why mass of substance deposited or liberated at an electrode is directly proportional to the amount of charge passed. If you want to write for current, then you can write current, and then you have to write that for a specific time period. Then it is okay. Next thing is second law, Faraday's second law of electrolysis. This law is applicable when you are comparing two cells, and mostly these cells are in series. The mass of substance deposited or liberated at an electrode on passing a certain amount of charge. Certain amount of charge means the Q is fixed now. It means I into T is fixed now, or I1 T1 is equal to I2 T2. Now, the mass of substance deposited or liberated at an electrode or passing certain amount of charge is directly proportional to its chemical equivalent. So, we will discuss more about chemical equivalent, how to do the numericals. Let us go with the next step, the numerical explanation for Faraday first law. W is equal to ZID. What is W? The mass. Mass deposited normally at cathode, and if it is obtained at node, that will be gas. So, Z is electrochemical equivalent. I is current in ampere, T is time taken in second. So it means that for I current is passed for time t second, DC current is passed through time second. And how to calculate Z is electrochemical equivalent, we have to calculate E by 96500. So E is what? That is equivalent mass. How to calculate equivalent mass? That is atomic mass divided by charge. For example, I am having copper. Copper, let us say I am having mass of 63.5. So atomic mass would be 63.5 divided by 2. Yes. And if you are talking of, let us say, silver. Silver means 108, atomic mass is there. So Ag plus is the charge. So plus 1 charge 108 by 1. So similarly, what is the atomic mass that will be given divided by the valency or charge, that will give us the E. And once you are getting E, if you divide by 96500, you will get Z. And Z, then you can get the mass deposited from a Faraday first law. And one more thing I would like to tell you, that 1 mole of deposition requires an F Faraday. So please note this point, always it will be used in the numericals. 1 mole of any substance required an F Faraday. N is the number of electrons in oxidation or reduction. Now, what is Faraday? Faraday is the charge contained in a 1 mole of electrons. So it is used in our electrochemical equivalents. Like here we have used that Z is equal to E by 96500. This is Faraday. Okay. Now how it is solved? So that we will come to know that how it is solved. So just see, Faraday is equal to 96500 coulomb. How we are able to get it? 1 Farad is the charge on 1 mole of electron. Charge on 1 electron is 1.6 times per minus 90 and 1 mole means 6.023 times per 23. If you multiply 1 Faraday you will get. And it will be 96495. To make it easy calculations and all that, we are rounded off to 96500 coulomb. That is 1 Faraday. Now question may come to you that define electrochemical equivalent. That is define Z. So Z is what? We have to substitute I is equal to 1 ampere, T is equal to time in seconds. So what would be Z? W is equal to Z. What is W? Mass deposited. So this way electrochemical equivalent is defined as the amount of substance deposited or liberated by a current of 1 ampere passed for 1 second, and that mass will come in grams. Now we will do the numericals for Faraday first law and second law. So numericals you try to understand, these are very easy. Once you are doing numerical, the full concept of electrolysis will be understood to you. Let us start. How many coulombs of electricity is required for reduction of 1 mole of 10 plus 4 to plus 2? So basic thing you should be aware that what happens there. Reduction takes place. Where it will take place? Cathode. Okay. So 10 Sn4 plus 2 electron gives N. So how many electrons are required? 2. So N is 2 here. 1 mole. Just now previously I have told you, for 1 mole of deposition we require NF. N is 2. So 2F. 2 into 96500 coulomb. This is the simplest problem you can find here. Next question is regarding to Faraday first law again. Calculate the number of coulombs required to deposit 5.4 gram of aluminium when the electrode reaction is Al3 plus 2, 3 electron give rise to aluminium. Given atomic mass of aluminium is 27 gram per mole, Faraday is 96500 coulomb. So how to solve that? 1 mole of aluminium requires NF Faraday. N is what? 3. So 3 into 96500. Now 1 mole of aluminium required 3 into 96500 coulombs, 27 gram. So we know that 1 mole is equal to atomic mass. 27 gram of aluminium required this much, 1 gram this much, and 5.4 gram we can multiply and get the answer. You will get very nicely. Okay, so this question, although I have solved in the basic, but you can solve by use of the formula. So that formula is W is equal to ZIT. So from that we can calculate W is equal to ZIT. W is 5.4, Z is E by 96500, and E is 27 by E is equal to E, we can calculate E is atomic mass divided by 3. Okay, and then we can calculate IT. IT would be the charge. So this way also you can try the formula. You can apply W is equal to ZIT. After substituting you will get, and you know the Z is what? Z is E by 96500. So here also we have. This is the one and the same thing only, but I feel that this is the better method than that. Now here, this is the numerical. 3 electrolyte cells A, B and C containing solution of zinc sulfate, AgNO3 and copper sulfate respectively are connected in series. These are cells in series. A steady current of 1.5 ampere was passed through the unit until 1.45 gram of silver deposited at the cathode cell B. How long did the current flow? What mass of copper and zinc were deposited? Atomic mass of silver is given, copper is given and zinc is given. So how to solve this type of problem? We have to apply the second law of electrolysis. What is that? W1 by W2. If you remember, the law states that second law W1 by W2 is equal to E1 by E2. Let us say, you can see from here, this see. W1 by W2 is equal to Z1 by Z2. Okay, so before that we can calculate first the current I. So how to calculate I? You have been given current as 1.55 ampere, and we have to get the first how long did the current. How long means time we have to calculate. W is equal to ZIT, you can substitute. So here W is equal to ZIT, we have substituted. 1 means silver we have used. So silver 1.45 was given, mass deposited, and Z is what? E by 9650. E is what? E is 108, atomic mass divided by valency, Ag plus, and then E we have calculated, and we can calculate time here. So once you are getting time here, so this first part of the question is solved. How long did the current flow? Now second is what mass of copper and zinc were deposited. So you have to use the second Faraday law. So second Faraday law is what? W1 by W2 is equal to Z1 by Z2. Or if the time and the current is same, then we can use E also. So because 96500 it will cancel out. So W of copper divided by W of silver is equal to Z of copper or divided by Z of silver. If I and T are same, then you can change Z with E also. So if you are in substitute, because I and T are same here, no time is different here. So E, then we are after substituting the value, E for copper is what? Atomic mass divided by valency, atomic mass 63.5 given, divided by 2. So we can get 0.426 answer for copper. Similarly, we can solve for zinc also. How to solve zinc? Zinc divided by silver is equal to Z of zinc and Z of silver and substituting. Now how to calculate E of zinc? Atomic mass divided by 2. So we have to check the atomic mass and the valencies. Hopefully you have understood this part. I have covered all the numericals related to that. More practice if you do, more understanding will come. Now summary. So basics of electrolysis we have discussed. Oxidation is loss of electron and oxidation takes place at anode and anion move towards anode. Similarly, reduction is gain of electron is at cathode and cations move towards cathode. Second point is Faraday's laws of electrolysis. W is equal to ZIT. Z is electrochemical equivalent, that is equal to E by 96500 coulomb. I is current, T is time in seconds. W is the mass deposited at cathode or liberated at anode gas. Faraday's law of electrolysis second, W1 by W2 is equal to Z1 by Z2, also equal to E1 by E2 if time and current are same or charge is same. Fourth is numericals we have solved about the Faraday's laws and applications, electrorefining, electroplating, galvanization and the prevention of corrosion. These are all factors related with this topic. And I would like to repeat the thought, a person who never made a mistake, never tried anything new. So making new things, making challenges, to solve the challenges and all that, we need to do something extra. So there might be some problems, there might be some mistakes that are acceptable. Okay, so thank you very much for your with me here. Thank you.